Hey Jen, I'm going to try to answer this for you. Hopefully this helps. I know it's hard to learn through video tutoring, but let's try it out. So all these questions ask for critical points, local extrema, inflection points, and then concave up and down. When I want these two, like critical points and local extrema, that means I need to take the first derivative and set it equal to 0. These ones, inflection points and concave up and concave down, means I need to take the second derivative and set it equal to 0 to find out everything. Okay. Then I'll show you how to sketch the graph also. So first of all, this is f of x. F prime of x equals, hold on one second. Okay, sorry. So first of all, if I want to take the first derivative, okay, what I gotta do is derivative the first one, 2x, the derivative is 2, and then the derivative of 3x to 2/3 is going to be 2/3 times 3 is 2, and then subtracting 1 to get x to negative 1/3. To find out where my critical points are, where it's increasing or decreasing, I set this equal to 0, okay, and then I have to solve this. So what I'm going to do is I'm going to rewrite this a little bit. Let me factor it. 2, and then I get 1 plus x to negative 1/3. So now by ZPP, I have two things that multiply to give me 0, so one of them has to equal 0. 2 never equals 0, so that's not going to give me any critical numbers, so I'm going to use this one. 1 plus x to negative 1/3 equals 0. I'll subtract 1. And then what I'm going to do is I'll raise both sides to the negative 3 power. So I'll raise this to negative 3. And I'll raise this to negative 3. And what I end up getting is that x equals negative 1. Okay? But every time you have a square root problem, like this one's like a cube root problem because I have 1/3, you're also going to account for the fact, so like this one right here is x to negative 1/3. It's the same thing as saying 1 over the cube root of x. Right? X to the negative 1/3 means that. And I'm trying to figure out when this equals negative 1. And you also do critical numbers. You also take into consideration not only when it's true, but also it makes it error, or where I get an undefined answer. And you know that x can't also be 0 here. So if I have 0 here, then I get 1 over 0, which is undefined. So I actually have two critical numbers. One when it equals 0, and also when it's undefined. So my two critical numbers are negative 1 and 0. Okay. Once I get, and these are my two critical numbers. Okay. So all I did, one was set it equal, take the first derivative, set it equal to 0, and solve for it. So I got negative 1. And also consider the fact what makes it, what else gives me an error undefined, and that's also 0. So that's how I get these two numbers. Let's get those two numbers. I didn't see this in your answer key, but what I'm going to do is I'll make a number line. I know that these are my two critical numbers. What I'm going to do is I'm going to test numbers in between, like so. And by testing these numbers, it'll tell me if it's positive or negative. It'll tell me if the derivative at that zone is positive, like it's increasing, or if it's decreasing, or whatever. Okay. Remember, this is my first derivative right here. So what I'm going to do is I'm going to plug negative 2 into here and see what numbers I get, and see if I get a positive or negative number. If I plug negative 2 into here, and you're going to have to put it in your calculator, I'm going to get a positive number. If I plug negative half in here, again, you're going to put it into your calculator, you're going to get a negative number. And if you plug in 1 in here, you're going to get a positive number. So without writing this all out, it's going to be increasing from negative infinity to negative 1, and from 0 to infinity. And this is decreasing in this minus zone from negative 1 to 0. So that's how you figure out increasing and decreasing. How do you know if it's a local max and min? See here, the slope is positive, and all of a sudden the slope turns negative. That tells me I have a max at negative 1. If I have minus and going to plus, like all of a sudden my slope is negative, and then my slope turns positive, that tells me I have a local min. So max at negative 1, and min at 0. Okay, so far? Alright, now let's do the second derivative. So we found that this was the first derivative, so if I find out the second derivative, I'll carve out a place right here. F prime double x equals, the derivative of 2 is just 0, and the derivative of this one is going to be negative 2/3 x to the negative 4/3. And then that equals 0. Okay? I can divide both sides by negative 2/3. And x equals negative 4/3. X has to be 0 for this to equal 0. Okay? And also, just like the last question, remember, because I have a cube root, anytime I have a square root problem, I also have to consider the fact if I have an error. This looks like 1 over the cube root of x to the 4th. And same thing, I also get 0 here. 0 would make this an error. So the only critical number, or the point of inflection I have is 0. Or possible point of inflection. Because it's 0, same thing, I'll make a number line. And I'll place that critical number here, 0. I'll test the number to the left and the right. To the right of 0 is 1, and to the left of 0 is negative 1. And again, I'm going to plug it into my second derivative, right here, and see if I get a positive or negative number. See if my second derivative is positive or negative. If I plug in a negative 1, you're going to find out that this zone right here is positive. If I plug in a positive 1, you'll also get a positive. Oh, haha, just kidding. No. Here. When I plug in a negative 1 here, I'm going to end up getting a negative number. When I plug in a 1 here into your calculator, you're also going to end up with a negative number. So that tells me 0 is not even a point of inflection, because from negative infinity to 0, it's concave down, and from 0 to infinity, it's concave down. So it's concave down everywhere. I don't know where to write this. Concave down, negative infinity, negative infinity, wow, to infinity. Okay. Now that you have all these, you have to figure out how to sketch the curve, and this is, I know that you said that you had problems with. Okay. So what I'm gonna do is I'm gonna turn to your, I'll turn to your key. Okay. I'll tell you how they got it. So what they did, let me zoom in. So what they did is they took notes on everything that they just found in that problem. We found out that we have a local min, remember we did this with you, at x equals 0. Or not. Alright, local min x equals 0. I have a local max x equals no. I know it's always concave down. Okay, these are the 3 that we did together. Okay. So what he did is he figured out, my critical numbers. Remember I had negative 1 and 0. I guess here they tested negative 1, 0, and 1, but I don't really care about that stuff. And let me draw that for you, actually. Maybe it'll be easier for you if I draw it. Can I? Well, let me delete this real quick, if it lets me. Okay, I'm running out of space here, so let's just use this space right here. So first of all, I'll draw an axis. Okay, and I know that I have a local max at negative 1, and I have a local min at 0. Okay, and the problem is that I don't know where that is or what the value is. So what they did in your key is the guy plugged in 0 and negative 1. When he plugged in negative 1, he got 1. So I'll draw that point here. When he plugged in 0, he got 0. And this won't let me draw it on 0, but let's just assume there's a little 0, 0 point right here. Okay. And then, remember we said it's increasing from 0 to negative 1? So it's increasing and it's concave down. So increasing and concave down looks like this. So my line, it's increasing, but it's concave down, and I have a max right here. Remember when we did it, we had negative 1 to 0 was decreasing? And remember, it's concave down everywhere. So concave down and decreasing, I'd make a line like so. Okay. And then, remember from 0 on, it's increasing and concave down. So increasing and concave down looks like this. So now I've satisfied everything that the graph asked me for. From negative infinity to 1, it's increasing but concave down. From negative 1 to 0, it's concave down and decreasing. And then from 0 on, it's increasing but concave down. So that's how I sketch this graph. So I don't know if this helps you out. I know it's messy and whatever, so hopefully that helps, and yeah, talk to you later, Jen.